Hello, this is Tim Sedlak with Microfocus. Today I'm going to spend a little time and demonstrate the second release of Microfocus's AD Bridge technology. So let's jump right in. The AD Bridge, as you recall, is one that extends identity, domain, and group policy services out to on-premise and cloud-based Unix and Linux resources. It allows you to take your standard Active Directory domain users and authorize them to connect and maintain these resources. Let's dig a little deeper into what that means from a benefit perspective. So the controls you have in the existing Active Directory now extend out to Linux, both on-premise and in the cloud. It allows you to take your existing tool sets. Here we see a screenshot of the dedicated web console, but you'll see in my demos, I use the native tools, Group Policy Management Editor, AD Users and Computers. So it lets me leverage my existing tool sets and maintain my investment and training that I have in resources to maintain a wide variety of resources now. Because you're bringing it all into a policy management framework, it does simplify security and configuration. It also allows you to reduce risk and simplify and ease compliance. And as I said, it's the first bridge that extends to the cloud for SaaS capabilities. So regardless of the resources you have running in the cloud, you can connect those directly to Active Directory. How are we different? With 2.0, we are the only vendor to allow coverage and visibility across your entire environment. Again, on-premise and cloud-based resources, Windows, Linux, whether they be VMs, applications, databases, whatever. You can take your existing AD configuration controls and replace the local management, the dedicated Linux accounts and set of scripts that generally people have to configure Linux boxes. We also utilize native firewall services and settings and IP tables. I'll give you an example of what that looks like here. And at all times, we're auditing what we're doing for simplified reporting, whether it be security or compliance reporting. So let's jump in and actually get a demo of the AD Bridge. I'm going to start with authentication and authorization. And I'll show you I'm connected to Azure, AWS, and Google, but it could just as easily be a private cloud. These are Linux virtual machines, and you'll see they natively join Active Directory. And that makes Active Directory the identity provider, even for the cloud, even for Linux. And it simplifies and organizes your resources because of the standard AD structure, the OU structure. Let me show you what that means. So here we are within Microsoft Azure, and I've got several VMs here within Azure. The top box that's highlighted here is ACO75-1. This is a CentOS machine running within Azure. And since I've got the agent, I've already natively joined Active Directory. And you'll see this is the box here, ACO75-1. These are the same whether I'm looking at it from the Azure or Active Directory users and computers. Here's an on-premise Linux server, an AWS Red Hat server, a Google Cloud Services CentOS box. All of these are managed, and I can provide access to my account, Charles Davis Admin, and you'll see as I look at the properties of users that we've added a property page that allows you to map a particular user. There's the AD Bridge page. That'll allow the mapping of user ID to GID if you've got things like home directory and map drives and those sorts of things. So with that, Linux is here. You'll see my ACO75-1 that existed here in my Active Directory Azure servers. There it is. And that's this box here that I've got a session into. Let me duplicate that session and I'll show you using my Active Directory Windows account. I'll just use my login name of CD admin. I'll get queried for the password and it'll communicate back with Active Directory. Again, this is not a duplicated account. This is my native Windows account, and it's the only copy of my native Windows account. So I don't have to worry about copying user accounts between machines. I know there are a few technologies out there that make use of that. So I'll get the banner back as to when I was last logged in, and I'll be provided with a command line here. Let me show you. I'll just run ID here, and that should come back and tell me a little bit more about this account. And you see, I'm actually belong to the group domain users. So this is my native Active Directory account. So now let me switch over and show you AWS. Similar sort of thing. I'll duplicate the session here, log in as my CD admin account, and it should prompt me for a password here as it negotiates the network path to get from my local box out to AWS, again, without a VPN. So enter my password, and once the communication happens to validate my account, even though it's a remote Linux box, this is a remote Red Hat box in AWS. And it should come back with the banner that tells me when I last logged in. Give it just a second here. And there we go, last login time. And you'll see as I run the ID command again, I'll get some information about me that tells me I'm from domain users. So once again, no duplicated accounts, no VPN, same sort of thing, same experience, whether I log into Azure or AWS or Google or private cloud or on-premise Linux. The experience is the same. So let's take a look at how we set policy. So this allows us to set some security controls and some configuration. You can set up things that when you successfully join Active Directory by installing the agent and connecting it, certain things get installed. Those that are familiar with Active Directory and group policy will recognize that policy flows according to an OU structure, so parent-child. So I'm going to give you an example here of creating a master GPO that's going to flow to all my Linux servers. And then I've got a sub-level here for cloud-based Linux servers. And then I've got a specific one for just AWS. Let's take a look at what that looks like. So here we are back in the group policy management console. And you can see I'll go create just a very basic group policy. This is how you start. I'll create a master Linux config policy. There we go. And that's at the top level of my OU, which means everybody in this test OU is going to get this policy. So I'll go in and edit it, and it'll open up in the Group Policy Management Editor. And you can see I have access to things like firewalls, where I can turn SMTP, HTTP, all these services on and off. Or I can create a custom rule and turn a specific port off or on, or allow it inbound or outbound only, limit the set of IP addresses. Then we give you control of services as well. So if there are services that should always be running, services you need to always make sure are stopped, or if you're making some configuration changes, you want to restart the services as part of policy, you can definitely do that. Now, configuration files, you'll see I've got a couple defaults where I can control SSH. I can allow certain users, deny certain users. I can also go in and set up some privileged access through sudoers and add a particular custom configuration file if I choose to configure particular applications or services. And we'll review this later. I've got a good demo on that I'll return to. I've also got the capability to deploy files. So if I've got files that need to be out there, I can have those files actually sent down to those machines through the mechanism we have. I can use the file picker here, set the destination, and then set the appropriate file permissions on those individual files. So I know they'll always be available on my Linux boxes. Now I also have the capability to execute some commands. This might be a good place for me, and I particularly have used this to do things like a yum install of a particular package, or maybe I want to do an update. I could even do something as simple as a host name and then pipe it out to an individual file. Now, I also have the run once flag over there. So this will only happen once. And then the last control you see there under Linux is the AD logins. And we've separated this out between on-premise and cloud-based resources. So with on-premise, it's pretty cut and dry. You'll see you can allow or deny users, or allow or deny groups from logging in. For cloud, it's similar but slightly different in that you can allow particular groups or allow users matching a particular LDAP filter to log in. That is what translates to the particular policy-based controls that we see in the AD bridge. Now, to dig in a little bit further on what we're doing, again, policy flows down. So within Active Directory users and computers, I've got my CD test OU01, where I've created a group for on-premise and cloud-based Linux servers. And if I go over to group policy, we can see the software or SSH rules that I have, and by default, I want SSH turned on my Linux boxes so that I can access them. So if I go into the firewall settings, you'll see what I have is allow SSH on the standard port. Let me expand this a little here to show you I've set it to allow. I could easily turn this off or switch it from inbound to outbound, but this is what I use in my particular use case to make sure I can access those boxes. Now, where I've got a multi-location firewall, if I go in, there are things that I definitely want to stop people from using. I don't want HTTP and I don't want FTP. And so because I've got both of these, as I go to my individual boxes here, we can take a look at the policies. And here we are in the AWS Red Hat box. I've got my deny HTTP and FTP and the allow SSH. That's set by policy. I'll go over to my on-premise box and you'll notice that it's exactly the same. So if you know what's happening on one box, you know it's going to happen on the other boxes. Here we are on the Google box, and there is my deny HTTP and FTP and allow SSH. And as we go to the Azure box, you'll see exactly the same thing. Again, a single configuration through policy has rolled this out and implemented it on a wide variety of servers, both on-premise and in the cloud, and regardless of cloud provider, they all get the same policy. So again, simplified configuration, uh, simplified security. So with policy, you can do things like force an initial configuration, a run once on join. In my case, I'll show you I install the Nano editor. And within AWS, I turn on Firewall D or install Firewall D. Now, these configurations are replicated for operating system, for custom applications or any services, and you can choose to do a complete configuration, so my entire configuration file flows, or just portions of my configuration. Maybe I want specific users or turn specific features on and off. Those files are locally cached. They're brought down with policy, stored in the sysvol. They're validated and continually updated as you make changes to the policy, and they're persistent. Let me show you how that's going to work. So once again, here we are within the group policy management console. And I'm on my cloud-based Linux servers. You can see I've got a couple of policies here for custom cloud app config and my Nano install. So what I'm going to do is go over to my Linux servers here for the Nano install, and we see that within AWS, I've got my Firewall D install. Let's take a look at what this install of the Nano package looks like. So we'll go over and edit and take a look at the execute commands, and you see very simply I've got the sudo yum install nano. I can add anything I want here to install other packages, lock things down, make changes to the operating system, and you'll see the flag is set to run once here. Similar sort of thing for AWS and its firewall. I don't know that I need to show you what that looks like. But all of those get the Nano install. So I know wherever I go, I've got that editing package, a very simple editing package everywhere I go. Here's where that policy ran, the sudo yum-y install, and that's on my Red Hat box in AWS. And it validates that it ran, already existed, same sort of thing. And you see I can run Nano here. So, it just exists automatically because I've connected it to Active Directory and automatically installed that. So that's pretty powerful that I can control my configuration just with a simple group policy. So let's take a look at custom configurations and how we can enforce that. What you're going to see is a file that I was given by security for a customer app, a custom app that we have. I added the source within a file picker and selected the destination. That gets wrapped into a GPO, gets saved locally and validated and persisted. So let's take a look at what that looks like. So here's the configuration for my custom application for my cloud app. I was given this, it's very simple setting, secure this app, is this cloud, nothing too complicated. But again, this could be anything that you have for configuration here. So that exists here. And I can go back into group policy management using the native tools. I've got GPO for custom cloud app config. Let's see what that looks like. So I can go down to deploy the files, and you'll see here's where I would go add the name of the file, go pick the file. It's the custom cloud app config, but I've already done this once, so it already exists. I'll set the directory and the file permissions, gets translated into a policy that gets loaded on each individual Linux agent wherever it exists, and therefore gets deployed out to the file system. So as part of this, if I need to restart HTTPD or any other services, I can simply do that here. All right, I'll close this down. And what's going to happen is we see the custom cloud app config got downloaded here. And one of the things I would like to demonstrate for you is how that is cached, persisted, watched, so that you can see how security is locked down through the policy engine that exists as part of our agent. So here's where my app lives, in the custom app directory. So I'll change to custom app, and you'll see that my configuration file exists here. I targeted where it would belong. And if you look at the file itself, you'll notice that it's not going to be a surprise that it says it's the gold image, secure this app, and is this cloud. Exactly what you would expect that came from the policy. Now, if somebody wants to be mean and hack this application, they gain access locally, they go into your custom app config, and they make a change, and what happens is this is no longer secure. And I'll go ahead and save that. And if I take a look at the file again, you'll see that it now has my extra line of this is no longer secure. But over on the left-hand side, you'll notice that we triggered a file watcher event. So this is part of the auditing. And what's happening is the group policy itself is saying, hey, do I need to maintain this file, or do I allow people to actually edit this file? So go back to deploy files, and you see that I can enforce the settings and maintain a local cache. So I'll go back here to my Red Hat box, and within 60 seconds, the file watcher will validate whether or not changes are allowed on that configuration file. And if not, it should replace the contents of that file with the fully approved version. Here we see the policy validating. There's the deny HTTP and FTP and allow SSH. And we'll also go back and say, hey, if there are changes to that configuration file for the custom cloud app, go put it back. And lo and behold, we're back to our gold image. So once again, you're able to lock down the machine. Somebody that had access and did something subversive with policy, within 60 seconds, you're able to put things back. That seriously decreases the window that somebody would have to attack your machines. So overall, we focused on a few different areas here. Very simple authentication authorization using your Active Directory accounts without duplicating those accounts anywhere. We showed you controls for security and configuration, and very simplified compliance with local files and services. And we showed you working across the entire enterprise, both on-premise and cloud-based resources. If you're interested, you can go learn more about AD Bridge at this location. Thank you for your time.